Welcome to The Explainer. So, today, we're diving straight into the hidden mathematical foundation of our modern world. And honestly, this is wild. The geometry that lets your phone know exactly where you are standing right this second, it wasn't cooked up in Silicon Valley. It was actually pioneered over a millennium ago. It's this incredible journey of how humanity figured out literally where we are on the planet, and it's absolutely going to change how you look at the tech in your pocket. Let's get right into it. Okay, so pull out your smartphone for a second and just picture a digital map. It instantly tells you exactly where you are, right? We take it totally for granted, but how did human beings accurately map the world long before space-age technology, before satellites and GPS ever existed? Like, how did they know where anything actually was with any kind of real reliability?
Well, to find out, we have to jump back over 1,100 years, right in the middle of the Islamic Golden Age. A brilliant scholar named Muhammad ibn Musa Al-Khwarizmi wrote this groundbreaking scientific guide. It's called Kitab Surat al-Ard, which translates to the Book of the Image of the Earth. And this single book, it fundamentally shifted how we view our entire planet.
See, before this book came along, mapping was kind of less about math and way more about mythology. If mapmakers didn't know what was in a region, they'd literally just draw a sea monster or label it "Here be dragons." Early geography was basically just a collection of traveler tales, local folklore, and really rough estimates. But Al-Khwarizmi, he brought a systematic, measurable, and totally evidence-based approach to the table.
Just imagine getting directions from someone and they tell you a city is, many days' journey toward the setting sun or somewhere near a big river. That kind of vague storytelling is exactly how the world used to operate. But Al-Khwarizmi completely revolutionized geography by taking those vague physical spaces and anchoring them to hard numerical data. He started systematically assigning specific mathematical coordinates to these locations, a total game changer.
His secret weapon here was latitude and longitude, numerical values assigned to physical locations to mathematically describe their exact position on Earth. And instead of just guessing, he used some seriously complex geometry. We're talking measuring the angles of the sun and stars with tools like the astrolabe to actually calculate physical locations on a spherical Earth. He was quite literally using the exact same fundamental geometric concepts that power your modern GPS today, organizing the known world into these massive, incredibly detailed coordinate tables.
And this leads us to a monumental shift in human understanding. It wasn't just about drawing a pretty map to hang on a wall anymore. As the texts from the era reveal, geography suddenly became something that could be calculated, verified, and improved. For the very first time in history, locations could be mathematically plotted and compared rather than just, guessed at.
But here's the thing. Al-Khwarizmi didn't stop at just recording what was already known. He actually took on the absolutely massive intellectual task of correcting the ancient world's mistakes.
For centuries, scholars had basically treated the maps of the Greek astronomer Claudius Ptolemy like absolute gospel. But those centuries-old classical measurements were aging really poorly. They just didn't match reality anymore. Get this, Ptolemy had actually drastically underestimated the size of the Earth. So rather than just blindly copying Ptolemy's outdated work like everyone else, Al-Khwarizmi applied new geometry. He respectfully revised the ancient work and created updated, observation-based geometric coordinates using fresh data gathered during the Islamic Golden Age.
In doing this, he was essentially building the foundation of the modern scientific method. Step 1, test the existing knowledge. Step 2, gather new astronomical evidence and observations. Step 3, refine and correct the coordinates. He didn't treat ancient knowledge as some fixed sacred text that had to stay that way forever. He treated it as something to be rigorously tested and refined through hard evidence. And honestly, that brilliant mindset remains the absolute bedrock of science today. And the sheer scope of this mathematical undertaking was just staggering. I mean, try mapping 3 vast continents using only the stars and an astrolabe. Kitab Surat al-Ard documented the exact geometric positions of major global cities, places like Baghdad, Damascus, Alexandria, and Mecca. His calculations literally stretched all the way across North Africa, the Middle East, Persia, Central Asia, parts of Europe, and the Indian subcontinent.
Plus, he meticulously mapped the natural world too. He calculated the geometry of everything: the winding Nile, the Tigris and Euphrates rivers, the coasts of the Mediterranean and Red Seas, the Persian Gulf, right across to massive mountain ranges and endless expanding deserts. It is incredibly hard to overstate the massive scale of Al-Khwarizmi's achievement here. He was plotting the physical features of the Earth with a level of mathematical rigor that was completely unprecedented.
Now, you might be wondering, why does this matter to the everyday person living back then? Well, let's connect this geometry back to real human impact. These precise coordinates practically changed lives overnight. We're talking about the absolute difference between life and death if you're navigating a harsh desert. For merchants, it meant improved trade and much safer, faster commerce routes. For governments, it allowed for better taxation, smoother political administration, and stronger defense. And for pilgrims, it meant safer, highly accurate travel toward Mecca. So this math, it had immense, immediate practical value.
So yeah, those immediate practical benefits were huge. But let's shift our focus for a second to the enduring legacy of coordinates. This body of work fundamentally changed the trajectory of human knowledge across all civilizations moving forward. It basically set off this massive, unstoppable ripple effect throughout the entire global scientific community. Think about it. This single body of work created breakthroughs on so many levels. The mathematical accuracy gave us reliable coordinates for hundreds of locations. His rigorous scientific methodology forced future scholars to actually verify their data, rather than just blindly repeating what the last guy said. And beautifully, his interdisciplinary focus proved that by studying the geometry of the stars up above, humans could perfectly map the Earth down below. It's like a giant puzzle coming together. And you can trace this invisible string of knowledge right across the centuries. It starts out with Ptolemy's rough estimates in the 2nd century. Then it leaps forward with al-Khwarizmi's geometric precision in the 9th century. After that, it gets expanded by later traveling Muslim scholars like al-Istahri and al-Idrisi in the 10th through 12th centuries. And eventually, this incredibly rich, updated data was translated into Latin, forming a direct intellectual bridge right into the European Renaissance. Knowledge travels, right? Every single generation builds on the last. Which brings our time travel narrative right back to the present moment. Because the reality is, every single digital map today still depends on the mathematical coordinates developed centuries ago. Sure, our technology has changed dramatically. We've got satellites orbiting the Earth, calculating our positions within meters, and digital navigation updating every single second. But the underlying scientific method, the idea of organizing locations systematically through mathematics, that remains exactly the same as it was over 1,000 years ago. So, I want to leave you with a thought to chew on. Next time you open a digital map on your phone and instantly find any location on Earth, ask yourself, did this incredible journey of mapping our world really begin with modern space satellites? Or did it begin with curious minds, careful medieval measurements, and a profound leap in geometry? Thank you so much for exploring this fascinating slice of scientific history with me today. Keep asking questions, keep analyzing the data, and we'll see you in the next explainer.